All right, so hello everyone. I'm super excited to see you here today. So as you can see, we have a feather, and the story behind this is the word lightness is too long, so I had to improvise. All right, so tell me, how many of you have tried SwiftUI? How many of you have production apps in SwiftUI? All right, that's what I expected. So just a quick recap. So it's been in our articles for quite some time, but we have a declarative approach. So instead of declaring how we're gonna show our views, we will say what we want to see in the end, and it has a very lightweight syntax. And the most important part is that it supports multiple platforms. Which is kind of true, but not really, because you still have to adjust to each platform and different use cases. But it's a big step forward as far as multi-platform support is concerned. So I'm glad that Apple is moving in this direction. So, and in case you were wondering what this code will show, this is the picture. I don't know if someone recognized the guy, but never mind. So besides the code itself, we have an extensive support for as far as Xcode goes. So we have these live previews. So for everyone who tried React Native, they know if they change the file or change the code, it will instantly update itself. This is kind of true, but it works similarly to first playgrounds, I would say. So it crashes a lot, but it's always been rough in the beginning, but it became better later. And once and for all, we can close the question whether to use storyboards or not to use storyboards, because you can modify the same UI either using the code, or you can click on it in the live preview and add modifiers, and it will update the code automatically. Also, SwiftUI in general has a lot of very weird errors. Everyone who tried it probably knows, and this should be better with Swift 5.2, which is already in beta right now. Okay, so let's think about it. So this is a simple view that, I don't know, it's maybe 9 lines of code. Let's think what we have to do in order to create the same hierarchy in UIKit. So we would have to create a UI image, we'd have to create a UI image view, we'd have to create a label, set the text to it, we'll have to create a button, we'll have to create a target for it. And it's quite a lot of code. We'll also have to manage all the constraints behind it. So I think it's pretty neat that you can actually put so much stuff into this amount of code. This is cool. On the downside of that, of course, you'll have to do some configurations in order to work with more complex views. All right, so let's start with some simple animations and how you can create them in SwiftUI. I kind of deliberately forgot to mention about the data management in SwiftUI, and one of the ways how you can do it is you have a state. It's a property wrapper, but basically it will allow you to, whenever this property updates, it will trigger a re-render of the whole view. And in our case, we have a button, which is like a tappable view, and it has an airplane view, which you'll see in a moment, which has a rotation effect. And if we go here, so it will create an animation. So at first it was 270 degrees, and it will rotate the view to 0 degrees because we're using the animation modifier, and we're specifying the animation curve as is in, is out. And we can specify multiple ones, which we'll get to in a moment. There are 2 ways how to declare an animation. One of them we saw before. It's like an explicit way. So you can add this modifier to anything that is animatable, or you can call like a with animation closure, which is similar to UI view animate, and it will change anything that is animatable while this update is triggered. So in this case, it will create the same animation as before, and they're interchangeable. So my advice would be to use the with animation closure when you have a lot of different animations and you want to animate them all at once. So these are different curves. They're pretty similar to what we have as options in UI view animate or to media functions in core animation. And you can also, some of them are customizable, some of them you can define an actual timing curve and customize it even more. So I think it's pretty good. This is the example of two different curves, and you can see that it behaves a little bit differently. I also think that the timings are probably wrong, but you get the idea. Besides the curves, you can specify different options for your animations. So you can have a repeat count, which is like how many times the animation will run. You can have a delay if you want to chain several animations one after another. And you can also specify speed. So in this case, the animation was supposed to be running for 8 seconds, but because the speed is at like a double speed, so it will run for just 4 seconds. And this is the result of the previous animation, which just rotates the airplane for 4 seconds. SwiftUI is very cool because you can have an interruptible animation out of the box. So if you are fast enough and tap on the animatable object, I mean, if it triggers this animation, so you can return it back to the previous state, and SwiftUI handles everything for you, so which is super cool. The downside of that is that you can't customize it in a good way. So for you to do that, you'll have to write a custom animation, which we'll get to in a minute. You can also chain the animations one by one. So if you have several effects, for example, in this view, I will show you the animation itself. So in this view, you have a rotation animation and you have a scaling animation. And by applying the animation modifier, it will, so each one applies to the previous effect. And you can customize the behavior. So here you'll have a linear animation for the rotation, and you'll have is in, is out animation for a scaling effect. If you pass just one animation modifier, it will apply to everything that is animatable before it. And you can also pass like animation nil, which will essentially cancel the animation, and it will be instant without the animation. All right. How many of you have done UI view controller custom transitions? How many of you liked the experience? Well, I mean, it's not for everyone, so it's much better right now because essentially the view and view controller is united, sort of, in SwiftUI. So this is how you do it. You can define a transition parameter, I mean, not a parameter, but a modifier for a view that you want to add an animation to, like an appearing animation. And you can specify what type you would like to use. And in this case, it's a slide. I will show you how it looks like in a minute. And notice that you still have to use with animation closure or have an animation modifier in order for it to make it work. If you just do the transition, nothing will happen. And there are some pretty good predefined transition types. So you can do like a slide, which will go from left to right. You can do a scale, which increases or decreases the view. You can do opacity to like fade in, fade out the view. And you can specify some custom offset. And here's how it looks like. So before, we would have to write a lot of code to move the view somewhere to the left, and then animate the, for example, transform of that view or animate its position, and then move it to the right, and it will still be in the hierarchy, but it won't be visible, and manage all this trickery with like previous view controller, current view controller, and now it's just a one line of code, essentially. Besides that, you can combine different transitions you can specify your own ones, or you can use the existing ones. So here we have an airplane which appears from the left. It fades in simultaneously, and then it fades out and disappears. You can also specify each animation for the appearance of the view and for its disappearance. And here, as you can see, it's like sliding from the right to left, and then it's being removed by shrinking. All right, so I'm going to show you some complex animations, or kind of complex-ish. In order to create something which is animatable, you have to, you guessed it, you have to conform to the animatable protocol. So it defines the animatable data property, and that property has to be vector arithmetic. So basically, it will allow you to do vector calculations like subtract, add, multiply vectors. And most of the views, most of the types already conform to it. So, for example, CJ float, doubles, angles, and stuff like that. But if you really are into it, you can define your own type to conform to these two protocols, and it will make it work with the whole SwiftUI system. So, if you remember, there was a UI view property animator, I think, in UIKit, and this is something very similar. So you can have, you will define your animatable data property, which is being set by SwiftUI from somewhere up top, and a modifier. So this animatable modifier conforms to two protocols, animatable and view modifier, which is the second method for the body. So what essentially happens is every time someone sets the animatable data, it then calls the body content method, and it will re-render your view based on the percentage. It's up to you how you handle the percentage, but so every time the render is called, and as you can see, it's not linear, but it actually uses the specific animation curve, and it's very cool that you can animate it this way automatically. The other cool effect is called a geometry effect. It's the same as a view modifier, the animatable modifier, but it has a effect value method to it, and it will return a projection transform, which is a matrix wrapper for the regular, like a fine transform or a CA transform 3D. And it's up to you how you define the transforms, but basically you have to have a custom implementation for each point in time, and it will apply this effect to your view. So if we take a look how it works, you can see that you can create a transition just like that. So basically the hardest part of this animation is the animation itself. You don't have to manage all this, have like different transition coordinators, delegates, and what's not. You just have to write your animation, and that's it. And it will define the active view modifier as a starting point, and then an identity modifier as an endpoint, and then SwiftUI will take care of the rest and like interpolate between the values. Okay, so the last cool thing which I'll show you is something that was shown on WWDC video last year, and it's actually so it's a complex example of what can happen if you have a lot of different views. Then the performance will degrade a lot, and actually it's still not perfect even right now, but basically if you will use a special modifier which is called .drawing group, you can flat the whole hierarchy of these wedges into one view, and it will render everything using metal, and it will be much faster than it would be normally. All right, so some final thoughts. I was very curious how it actually works, and like I was able to get some info, but not all the info. So I was examining the view, the SwiftUI view, and it's actually backed up by UI view on iOS. And as you can see, the most interesting property there is a layer. And what it does, it uses a custom layer for that particular view, so which is SwiftUI image layer in this case. And what I found out is that during all those animations, rotations, they almost never use core animation APIs. So they have something above that, or they're going straight to metal rendering. And this is what actually makes some of the views faster in SwiftUI. But if you thought that the UI kit is gone, well, it's still there. We just don't see it. So I guess the future is really bright. We have a solid foundation as far as like animations are concerned. It still lacks some customization support. For example, we don't have keyframe animations. We don't have like a way to animate, let's say, gradient properly or easily. But I hope they will unveil something at this WWDC this year, and we're gonna see SwiftUI. So fingers crossed. As far as inspiration goes, I used a tutorial by Apple, which they have a really cool tutorial this year. And SwiftUI Lab is basically a go-to documentation which Apple has never written. So check it out. That's it for me. Thank you. Anyone wants to ask tricky questions? No? Okay. So I'm going to pass my word to Jan Timar.